situation, you'd be taking a coal and gasification cycle combined power plant uh, and adding H2O to the carbon monoxide and hydrogen, as I've already said, and removing it so the two are separated. In a post combustion, in the flue gas, which is going up through the haystack, ammonia is inserted, and the gas becomes superheated, which separates the CO2 from the rest of the gas and allows an absorber column to capture the CO2. This is then transported and stored elsewhere. How exactly they utilize that is up to them. Where they put that is up to them. But there are definitely different methods that could be used in that regard as well. Whether it be stored as a solid through some sort of chemical reaction with the carbon, storing CO2 in a solid form is impossible unless it's in a very specific facility that's called dry ice. So in natural conditions, that doesn't exist anywhere in the natural world. So they do some sort of chemical alteration where they could actually make it into some sort of solid that's similar to plastic. And then lastly, or actually no, second to last is oxyfuel, which is focused on coal plants that burn coal in nothing but oxygen, 100% oxygen, and that results in CO2 and water vapor alone. There's no other gases mixed in, and the water vapor can be condensed with leaving just CO2 gas, and that can be transported elsewhere and chemically altered. And then lastly, the salt mix method, which involves obviously inserting some kind of salt filtration system uh, along with chemicals like phosphorus, uh, which would filter the flue gas that comes from a coal burning plant or gas burning plant, and in that way or another, that post combustion method could work as well. That one is still in the works. It hasn't been approved by any company in the U.S. up to this point, to my knowledge. Um, in Europe, I want to say Norway, they started using that, and it's shown to be quite effective. And it costs less because it's less energy intensive. It's been shown to work actually at um, room temperature, which is extremely different than the other very energy intensive processes, which would naturally require cooling systems to be put in place because of the anticipated heating that happens when working with these hot gases, such as the ones that come from the insertion of ammonia in the post combustion process. Uh, Direct air capture cost estimates. So, not the methods I just talked about, those are non direct air capture, but I'm going to speak more to the most innovative one, the one that I want to focus on the most. Uh, its cost estimates range anywhere from $100 to $300 per metric ton of CO2 removed to as much as $800. And the disparity exists because the efficiency of plants up to this point or facilities for this technology have not been consistent. Um, and the size of them makes a big difference as to how much carbon they could get in, how efficient they could be. So I guess the initial amount of money you're willing to invest in something like this ultimately has a great impact on how efficient uh, the removal is in terms of dollars. So if you're willing to invest more upfront, then you'll likely have a better outcome in terms of efficiency later. Uh, but projections have shown that some believe that the future cost of this could be as low as $49 per metric ton. And to put that in perspective, uh, 1 metric ton of natural gas can be sold for $87 roughly. And that's based off of 1 uh, million metric British thermal unit of natural gas being sold at $1.74, which is 1/50th of a metric ton. So if you do the math, 1.74 times 50, that comes to 87 roughly. Um, so that means you'd be taking it out of the atmosphere for $49 and reselling it potentially for 87. So you can actually make money off of doing this if the projections hold up. Once again, there's a lot of uncertainty just based on the fluctuation in estimates for current costs. That should show that there's still a lot of unknowns around this technology. With that said, if we focus on investing in this technology and trying to propel it forward and figuring out the true repercussions of it, whether it be CO2 depletion, which comes from just taking CO2 out of the air from one area, concentrated area, and a lot of it. That's been shown to occur at times. And then also, like, there's other issues that don't really get solved, which is the reliance of fossil fuel in our economy. So it still keeps the fossil fuel power plants in place. It keeps them still making money. Doesn't remove them from the equation. Problems that come from that obviously are they've been shown to be unethical in the past. What's preventing them from being unethical in the next steps to be taken? You're kind of making a deal with the devil at this point. I don't know what the ultimate repercussions of that will be, but it's something to keep in mind. Uh, Once again, we don't want to totally upend our entire lives in order to address this. With that said, we want to make sure we're effectively addressing it. So there's a balance here, and we realize that, and that's why we want to promote these messages that try to endorse the fact that people have some anxiety about all these transitions and changes that are coming about, while still being staunch on the fact that this is an issue that must be addressed. We understand the concerns about just promoting a certain idea and not thinking twice about it and not really analyzing all the problems that may come with it. Like, this also, once again, is not a one size fits all solution, because it doesn't address the fact that when this does get installed, let's just say on a mass scale, if other things don't go along with it, like the electrification of all our cars and all our transportation, there's still going to be plenty of emissions coming from that sector of society. So even if the energy sector gets on board with this and the transportation doesn't, it doesn't totally address the issue. And then lastly, other hazardous chemicals could still enter the atmosphere even when doing this. So like NOx and SOx for acid rain, those are acid rain causing chemicals in the atmosphere. Our atmosphere could still be very unhealthy even upon removing all emissions and even reducing the amount of emissions that or CO2 content that's in the atmosphere. So that's something to look out for as well. This is not solving all the issues that we have. What it can solve is climate change and global warming. So the heating of the planet, that might be solved, but it doesn't mean that there's not other issues that may arise even when the temperatures are to stabilize and the CO2 content is reduced. Yes, so that's all I have to say about it. I hope that this gave you a little bit of an insight on this entire technology and what it can potentially provide, what its shortcomings are, and yeah, thank you.